Hey everyone, I'm here with TM Lee, one of the co-founders of CoinGecko. He'll be doing a talk on ingesting data, thinking through the design of a data-driven product at CoinGecko. And I'll let him take it from here. Can you guys confirm in the chat that you can hear him once he starts speaking?
Hi everyone, can you hear me? Is the audio working? And can you see my slides?
TM, do you want to start talking?
Can you hear my slides? Can you see my slides?
Yes, I can see your slides.
All right, great. Okay, so I'll just kick off then. Hi everyone. So in today's presentation, I'll be sharing a little bit about what we at CoinGecko have done, and in terms of thinking through some of the methods in terms of approaching bringing the data from various different sources into CoinGecko to be presented to everyone through the website. And the objective here is that we want to achieve like an example of this, right? Like Uniswap data. Like how can we get the 3,290 pairs data points into CoinGecko, and not just Uniswap, but all the various other like centralized exchange, derivatives, DEXs, and so on. That will form the majority of the discussion in this presentation. And when we look at data ingestion, we typically look at it in three ways, like simplicity, maintainability, and scalability. So simplicity in the sense that if there are maybe like 5 ways to obtain a certain data, we always go for the one that is the simplest, even though if the simplest option is a little bit less efficient, and the harder ones are much more efficient. Right? And the reason for that is to ensure that things are maintainable on our end. The reason for that is also we currently have integration with over 500 different data sources, and a lot of things can go wrong as we go by, like API changes, or the data that comes back on the other side is something that we don't expect, or there could be dependency issues as well. So we always opt for a uniform approach where all the exchanges are sort of implemented in the same way so that we can easily maintain it and scale it by adding new modules into the data ingestion. Here I have the basic blocks of a data ingestion system that we use over here, and I think it's pretty much similar to most other systems out there. In order to get the data into our database, we always have to start with looking at the data sources first. So we have to study them and find out like how the data structure is like. Sometimes they can vary and things like that. And then the middleware is supposed to take all these different data structures from all these different API endpoints. So you can imagine that Binance, Coinbase, and Kraken, they all have different standards and they all have different ways of presenting the data back to the developer. And the middleware is supposed to unify them into a common standard that we want to use on our end, right? So that's where the middleware is. And then you will have a queuing system, and it's typically a background processing job where it will go ahead and fetch all this data from all these different exchanges in parallel concurrently. By that, you can then scale across as many exchanges you want by just throwing in more machines, and you can do all of that in background. And finally, that data gets stored into our database, which you can then massage it or process it, do some aggregation, removing outliers, and then present it as a market data out there. So when CoinGecko started off, we focused mainly on the spot market. So as you can see in the spot market, the kind of data points that we get back from the exchange are like last done price, the trading volume, the order book on the ask side and the sell side and the buy side, the trades that have been executed over a period of time. So that's specifically for the spot market. And then later on, we decided that we want to also track derivative markets as well. So we started tracking BitMEX or Binance Futures and FTX. And suddenly we found ourselves that we can't really reuse everything that we have written for the spot market because there are new kind of attributes that we need to take into consideration, like the contract price or the composition of the index. Like, is it a index that has a multitude of tokens in there, or is it an index that tracks a given token, the open interest, the funding rates? So you can imagine that we will need some sort of a new kind of middleware to manage all these different new attributes that is different than the spot market. So we'll have a module for the spot market, and we have a module for the derivative that acts the middleware to be input into our database. The data ingestion universe just kind of keep expanding, right? We start off with spot, and then we move on to derivative, and then now with the advent of DeFi, there's more and more activities going on the Ethereum chain. And it's really spearheaded by the automated market maker due to the fact that it is very easy for people to create a market and create a long tail of tokens to be traded on with Uniswap. So with that, we found ourselves that whatever that we have developed for the spot market and the derivative market cannot exactly work anymore for data that we acquire from the Ethereum chain. So this begs the question, like, how are we going to bring in DeFi data into CoinGecko? So this will form a majority of the discussion, and I have two options for you. And option number one is to look for an API services that looks very similar to what we have dealt with the spot market and the derivative market. And the reason for that is also because things are much more simpler as well. Like we don't have to figure out how to work with a smart contract or write something very extraordinarily different than what we used to. So this example I have here is the Graph protocol, and we use this extensively at CoinGecko. So the Graph protocol is basically currently is still hosted by themselves, but I think by the end of the year or next, they will turn into a decentralized network where what they do is they index the entire Ethereum dataset, and then developers can then contribute this thing called a subgraph, which sort of like a middleware that I explained earlier, that organizes all this data from all these different DEXs into the kind of format that we expect as developer ourselves. So to give you an example here is that the graph would then allow developers to use GraphQL, which is a query language that requires a little bit of a learning curve, but isn't too difficult for a developer to learn. You would then use this GraphQL to specify what sort of attributes you want to obtain from the graph. So you can say that for a given contract or a given token, for Uniswap, give me the price, the volume, the liquidity, and so on. And here is an example of how it looks like, right? You query the GraphQL, and then at the end of it, you get processed data that is really, really nice to work with. Like you get the symbols, you get the liquidity, you get the volume. You can generally use this directly and plug it into your application and then serve it straight to the user. So this is great because it looks very much like the API that we worked on in the spot market and derivative market. And developers on our side can just come in, integrate, and move on to the next DEX, and so on and so forth. There are a couple of downsides to this approach, which I will explain later on what are the pros and cons between the options out there. Option number two would be reading data directly on-chain, and this will be working with raw data that won't be as pretty as what we saw earlier. So your options here are two main components. I separate them. So the first one would be non-index data, right? So to get this, you would need to run something like a full node. So it could be a parity Ethereum or a Go Ethereum, where you have to maintain the node maybe in your systems, or you can use cloud services, but you need to have that storage available to store all this Ethereum blockchain data and then be able to make RPC calls to get whatever data that you want from the Ethereum history. If you don't want to manage those nodes, you could use a node as a service like Infura or Alchemy, which gives you the same capability as having a full node as well, but without the hassle of actually maintaining a node and making sure that it's synced at all time. So at the end, you are going to get an interface that you can make RPC calls to obtain a bunch of data. But keep in mind that all these data are not exactly indexed in a database per se. Like they're all, you're making calls directly on the chain. So things can get a little bit inefficient and it can be a little bit slow depending on the query that you make. But you get like full flexibility on what you want to query and what you want to achieve, and then dice it later on. The other option that you can opt for is services like Etherscan or Covalent. So both of them sort of index the entire Ethereum blockchain into a database on their end. So the end result is you could still get something very similar to what you would query using RPC calls on the node. But the nice thing about this service is that you don't have to care about running a node at all. Like you don't even need to know what an RPC call is. So to give you an example is in the Etherscan and Covalent example, you would only work with it using a HTTP API. So it's very similar to calling an API endpoint and getting a result back and then work on those data. Whereas on the full node side, you will need to make RPC calls. And the reason why we don't use that in CoinGecko is because our stack is in Ruby on Rails. And I couldn't find any simple library to just do specifically what we need to do, which is to get data from AMMs. But you can imagine if you are using a JavaScript environment like Node.js or Go, I think there's very good support in terms of having a library to connect to the Ethereum using a full node. Otherwise, if you use HTTP API, you're pretty much technology agnostic because you're just working with querying an API and getting a data back. And as long as you can pass those JSON data, you're pretty much good to go to work on it and build into your application. Some of the things that you have to keep in mind is that when we look at the graph earlier, like you don't necessarily have to care about how the contract is being written, right? You just specify to the graph that you want the data for a given contract, and you get all this information automatically calculated for you. In this case here, you have to do a lot of the manual work by yourself. Like you need to find out what are the contract address for the factory, which is in AMM term is the contract that generates the pool. And then you have to go into the pool and study the contract and look at the events that are being emitted. So in short, you have to sort of like understand what the contract is doing, what sort of data it's emitting in the log, and then pretty much calculate everything yourself, like what is the last done price, what are the volume. You have to sort of make a query to get all the trades that has been executed in the last 24 hours, and then sum them up to get the total volume in the last 24 hours. So a lot of all these things that you got to do it manually if you go with this approach. So to give you an example here is the kind of data you're going to get back would be something of this form. Like it's not human readable, and you have to sort of like process it in code. Of course, you could also use Etherscan's interface to sort of like decode a bunch of all this hexadecimal value into a human readable number. But as a developer, you have to manage all this yourself. Like you gotta decode them, and if you need to include a ABI to decode something that's much more complicated, you have to take care of all this yourself. So over here, I have a summary of the Ethereum data landscape in the way that we look at it, right? So you can imagine this scale, a spectrum from on the left being the hardest for a developer to get started, but that gives you the most control. And then on the right side will be something that's much more opinionated, which means that you as developer may not have the flexibility to get what you want exactly at a given time. But it's really simple to get started. Like you can just plug in an API, or you just make queries and you can get the data automatically. So in CoinGecko, we actually use both the graph and also Etherscan to some extent, mainly because for the graph, all these subgraphs are being contributed by the community. And there are instances where the subgraphs could be doing too much or could be doing something that doesn't suit the use case that we're looking for. And that is why we have to fall back to using reading the data directly from the chain to get all this data and process them to support exchanges that are not being tracked on the subgraph. But I can imagine that when the network launches and when there are incentives and stuff like that, maybe more and more people will start to write subgraphs for the graph. But that really depends on how things go when it launches. And for Dew Analytics and the graph, both of them have pretty vibrant community that contributes all this thing called a subgraph or a module in order to give user the kind of data that they want. But if you really want full control as a developer and you want to be able to get the kind of data that you want, regardless of what people are doing, then anything on the left-hand side will be of the best option for you. So as we keep adding more and more exchanges, adding more and more modules, we find ourselves living in a universe where it just keeps expanding, right? So we start off with spot, and we move on to derivative, and then we move on to DEXs on the Ethereum space. And I think one thing that kind of got us thinking is, how would the universe continue to expand? Like when Ethereum 2.0 launches, are we able to capture all this data that gets distributed across different shards? We don't exactly know yet how things will look like, but that is something that we have to keep in mind. And then all the other chains that are also emerging to compete with Ethereum, right? Like Polkadot, XDAI, Binance Smart Chain, or even like layer 2 solutions. How will all this data how will all the activities that is happening on all these different chains get accounted for? Remains a huge challenge for us to figure out how we can capture them. And another thing that we're also starting to see will be contract-based bonding curve. So there are tokens like Nexus Mutual or Avagochi, or even like Y-Curve LP token that have their own sort of like a bonding curve. And the price there is always going to be much more efficient than what is traded on an AMM. And that is something that is very different than what we have seen, because in the earlier example, they are mainly like trading activity between people, like a swap or a trade. But in this case, you're actually trading against a formula. So this is a new trend that we're seeing, and we are also starting to integrate this on our end. But I can also say that there will be an explosion of all these kind of contracts moving forward down the road. So in terms of challenges as a whole, to summarize, I would say that the data ingestion problem continues to just evolve from week to week, month to month. The DEXs could come in many, many different flavors. Like it could be an order book based, or it could be an AMM. It could be a spot market, or it could be a synthetic market. So there's just a lot of changes and fluidity that we can't really settle for one like universal module and ensure that it will work across all situations. Like we are always constantly trying to experiment with different ways to plug all this data into CoinGecko, and that remains like one of the constant challenge for us as things go by. Not to mention, if we were to look at other type of asset classes like non-fungible tokens, I think that's a whole different beast itself. That there could be other projects out there that are doing really good job in tracking NFTs, but for us, this is something that we are not currently tracking, but we need to start thinking about it as more and more market activity gets accrued there. Next one is scaling token curation. So as we expand the universe, we're probably going to see ourselves adding more and more tokens every day and every week. And we're almost living in a situation where almost everything that can be tokenized will be tokenized. And the question is, can we actually keep up with indexing all of it across the decentralized universe? And also, can we, as a team in CoinGecko, be able to curate all of them to put all the proper information in place? So this is not exactly related to data ingestion, but it's more of an operational problem that we are facing on our end as we scale the data side of things. And as I mentioned, the last one earlier here, multi-chain, multi-shard, cross-chain, there's more and more competitions emerging that tries to compete against Ethereum. How would that space look like remains a little bit murky, and we are starting to integrate a few new chains as we see more and more activity going on there. Again, back to the question that there is no one-size-fits-all solution, and we just have to write modules after modules and making sure that they can be maintainable as we have all these different modules to maintain over time. And yeah, so lastly, I wanted to share is that you can go ahead and use our API if you want to access any sort of market data. All the heavy lifting for aggregating the market data and detecting outliers are taken care by us. And if you just want to acquire pricing information or for any tokens that we support, just plug in our API and you can get access to them really, really easily. So with that, I hope this is useful to all of you, and I'm ready to take any questions. Thank you. Yeah, so one of the questions that most people like generally throw at us is that like all the data is on chain, right? Like you should be able to acquire those data directly from Ethereum and put it into CoinGecko. So these are some of the misconceptions that people throw at us. But as I explained earlier, that a lot of all these smart contract can work in very different way and have different, that requires different modules needs to be written. So I would say that for a new kind of data that we need to track, the first thing is that is there a subgraph out there, which means some other developer has already understood the smart contract and wrote a subgraph for that we can easily just port it into CoinGecko. If the subgraph is not there, then most likely what we have to do is to study the contract ourselves and then acquire those raw data, understand the events, and write things on our side. And that obviously takes a little bit more time for integration. But basically the misconception is, doesn't mean that the data is on chain, we can easily index it right off the bat due to legacy problems on our end, and also the fact that we need to understand some of this data format as well. Yeah, if there's no other questions, I will conclude this session, and thank you for your time. Hopefully this has been useful to you one way or another, and hopefully that can help you build your next application that regards to data.
So I have one question, and there's one more question too.
Oh, okay. Yeah, I'll answer the one in the chat first. How many views is CoinGecko website currently receiving daily? I haven't really been checking the metric, but I would say that compared to earlier this year, the traffic has definitely gone up like 10x or more, just due to the sheer interest in DeFi. So a couple of million page views per day, I would say, yeah.
So I have a question about on-chain data, because I've been looking into the graph. When a new subgraph is created, how long does it take before it's actually usable and useful for someone like you guys?
So as far as I know, when a subgraph is being written, if everything checks off, what they need to do is to deploy the subgraph to the network, and I think it's running on IPFS or something, and then it would then have to synchronize. So what happens is the subgraph will specify the kind of data attributes that you are interested in, and then it needs to traverse back to the history to go through all the logs and then put them in the order that you want it. So it takes maybe like half a day or a day, depending on how much data there is, to catch up. And then once everything is synchronized, then we can then plug that in and obtain those data and display it on CoinGecko. So from my experience, it takes like maybe a day or half from the ones that I've worked with. Yeah.
Oh, okay. That's really fast. Okay, interesting. Cool. I think that's pretty much it. Thank you so much for your time. It was a really great talk.
All right. Thank you very much.
All right, cool. So this is a wrap. We'll see you guys tomorrow at 9 a.m. Thank you so much again. It was great.